Hey everyone, I wanted to hop on and make a quick video for some of our Delta Math practice today, which is going to be based on the word problems from exponential functions that we started yesterday. Huge disclaimer, I'm out sick today unexpectedly, but one thing that I wanted us to do is to do your Delta Math practice on paper and pencil today. Okay, so you need to do this on paper and pencil because you will be turning it in before you leave today. Okay, super huge. We just have 15 problems to do. We have 15 here and 5 here, and just so that this is straightforward and not overwhelming, I'm going to make 2 separate videos. So this is one of 2. So let's get into section 1, which is just like the basic exponential functions, piecing together the information that we learned yesterday, just so you can kind of get the gist and figure out how to break down these word problems. Okay, again, we're only going to have 10 questions. There's no penalty if you get them wrong or if you need to redo them. And I wanted to just remind you of a couple cool features that are available on Delta Math for you. Okay, so here is an example of a question. You'll see an element with a mass of 590 grams decays by 19.5% per minute. How much of the element is remaining after 15 minutes to the nearest tenth of a gram? Before I jump into this and tell you how to do this, there's buttons at the top. There's show solution. There's see example. Again, I want to remind you there is no penalty for using any of those things. And so you should. So if you were going to click see solution, you'd have to stop, read, and figure out what exactly they're doing or seeing how they're rounding. And so that's just something I wanted to remind you of. But let's just give this a go. Here, remember, we know that with exponential functions, we have y equals a times b to the x. And so that's what we're going to set up. A is our initial amount or initial value. So for this, we're talking about some sort of element, and it says it has a mass of 590 grams. It also tells us that it's decaying, and it's telling us that it decays at 19.5% per minute, and we want to know how much is remaining after 15 minutes, okay? So I kind of like to lay out all of the given information and color code it. So we do know that just based out of all of the things that we have here, the initial value is how much the element weighs to begin, because we want to know how much is left after some time. So we have 590. I know that it's decaying, so that means my base is going to be less than 1. I know that it's decaying at a rate of 19.5%. Part over the whole gives me 0.195 in my calculator, or if you were following along with the decimal movement trick, because we're doing dividing by 100, you move the decimal place over 2 spots to the left. And we also want to know after 15 minutes. Okay, so you might know right away that our initial value goes first, 590. Then we're going to need to fill out our base, and our exponent is how much time is passing. The trickiest part here is going to be the base. So since the base is less than 1, because we're talking about decay, we're going to have 1 minus our rate. Okay, decay, we need our base smaller than 1 minus our rate. This means we're going to have 1 minus 0.195. And if I do 1 minus 0.195, In my calculator, I get 0.805, because again, we're going to need PEMDAS to figure out actually what this is. So the first part of PEMDAS is your parentheses. Simplify this value within the parentheses. That is 0.805. Then we've got to apply the exponent. So whatever 0.805 raised to the 15, just punching this into my calculator. This gives me a bunch of decimals. You don't have to necessarily write this down, but I will. I got 0.038 631200596. That's what my Desmos calculator pulls up. And then we've got to do multiplication. So this times this in my calculator. I have 590 times that decimal. And that gives me 22.792408358. Okay, now one very important thing that you're going to need to pay extra close attention is they're going to tell you how to round. This is to the nearest tenth, which means 1 decimal place, right? Because 10 has just 1 0. So that means I'm talking about just 1. Since this is 7.79, I'm going to need to round that up to 22.8. The number inside the box goes up. If the number outside of the box, the first number is 5 or higher, you round it up. If it's less than 5, you keep it. And we'll look at our solution. Notice that we did have 22.8. So again, the solutions remind you that like, hey, we're working with this function. We do know that A is the starting value right here, and then we found out that that was 590. We also took the rate was 19.5 and converted that to a decimal just like we did. We also talked about, hey, if we have decay, we're going to have 1 minus our rate so that the base is less than 1. And then you can see they're just plugging it all in here in the same exact way that we did. So you'll probably find some problems where either they're decreasing, those are going to be decay. Again, you're going to use 1 minus the rate. On the other hand, you might have problems where you're going to end up with exponential growth, such as this. $9,000 is placed in an account. We have an interest rate of 7.75%. How much will be in the account after 8 years? To the nearest cent. Again, money is going to be growth. Money's going to be growth for the most part, unless we're talking about like the value of a vehicle and it will say like decreasing or things like that. So if you see problems that are like this, they're going to be growth. Remember, you can also hit the C example or C solution and you would kind of get a walkthrough that looks like this from Delta Math. But let's just start off by saying like, what information do we have? We know we have y equals a times b to the x. And depending on what it is, it's either going to be 1 plus the rate or minus the rate. So I'll kind of put this here for this example. And we need to just start off by saying like what A is, our initial amount. We have $9,000 in the account. We have our interest rate of 7.75%. Part divided by the whole. That's going to give us 0.0775. Remember, when you do that division, this moves the decimal 2 places to the left. We also want to know what's going to happen after 18 years. So x is going to be 18. And this is going to be growth. It's money, so that means we're going to be adding because we want our base to be a number larger than 1. So let's put it all into our equation. Y is equal to 9,000 times 1 plus my interest rate, which is 0.0775. And we're going to raise this to the 18th power. To actually get our answer, this is where PEMDAS comes into play. Parentheses, exponents, multiply, then or divide, whatever comes first from left to right. Add and subtract, whatever comes first from left to right. It's probably just going to be the multiply, but you never know. And we first start with the parentheses, simplifying the parentheses. This part right here, that's relating to our base, which we know it's going to end up being larger than 1. So if I simplify that base, that's going to give me 1.0775. That is a number larger than 1, so that does match our intuition that this is going to be exponential growth. Then, according to PEMDAS, we're going to move into exponents. So take this base, raise it to this exponent. This is going to be just a calculator problem that you're doing in either your scientific calculator or Desmos or a tab on your computer like I'm doing, 1.0775. And remember, I want to see your guys' work. You have to turn in your work today. I want to make sure that we're actually practicing in class and making sense of this. I got 3.832 754 6 804. Yes, there's going to be a lot of decimals. It's okay. And then the last part of the PEMDAS that we have is parentheses just mean multiply. So I just need to multiply these guys all the way together. So I'll take that amount and I'm going to multiply it by 9,000. Oops. And I end up with 494.7918,324. Again, this is telling you exactly how far to round, so you're going to need to be very careful and read every single problem. It wants you to do it to the nearest cent. So for that, that's 2 decimal places, because money has 2 decimal places. So again, I find the decimal and I'm going to put a box around those 2. That's how many I need. I look to the next one over it, the one I'm underlining, and if that number is less than 5, I keep it, whatever's in the box. If the number outside of the box is bigger than 5, I need to up that number 1 more. So right now, the number inside the box is 79 cents. Since the number to the right of it is less than 5, I'm going to keep it 79 cents. If the number to the right was bigger than that, I would round it up to 80 cents. So my amount should be $34,494.79. Let's check with the solution. Sure is. And I would get this right. Now, let's say you got this and you didn't round correctly. Again, there's no penalty. So don't worry about getting it wrong. Worry about understanding how the process is. Again, if you're going to do growth, if it's a growth problem, things are getting larger, it's going to be 1 plus your rate. If you know that something is going to be decay, like our first problem, it's going to be 1 minus your rate, because that's going to force us to get the proper base. And it might just be very upfront, like this problem. New car is purchased for this many dollars. The value of the car depreciates. That automatically means we have decay. It's going to be 1 minus our rate. Our rate is 9.25%. Going to have to convert that. 9.25 divided by 100. That's going to give you 0.0925, right? And then we want to know after 15 years. So we're going to raise it to the 15th power and have the number right in front of here, 17300. Again, click solution. You'll see that's exactly how they did it. 17300. They did 1 minus. That gave us a decay base, and base less than 1. And then they plugged in for x, the number 15, and round, however it says. This one says to the nearest cent. Bada bing, bada boom. This is the first section where you have 10 problems. I'm going to make a separate video for the second section, but setting up the first section like this will help you be successful.